You may think you already know our planet well, yet nearly 70% of Earth remains out of sight for most of us. It is not merely a matter of people not having visited these places, rather, they are regions so extreme that humans rarely dare to enter them. In the deep ocean, especially below 6,000 meters, the environment becomes so harsh that only a handful of people have ever gone there, fewer, in fact, than those who have set foot on the moon. NASA once made a striking observation that resonated across the scientific community. In some ways, humanity knows more about the surface of Mars than about the deepest parts of Earth's oceans. Compared with what we know about the surface of other planets, we still understand surprisingly little about the seabed of our own world. So why do humans hesitate to explore it more deeply? One major reason is that the life forms living there have evolved in such extreme and unfamiliar ways that they can make you question whether this is still Earth at all. Some deep-sea fish can produce light that remains invisible to most other creatures, while they alone can detect it. Their prey has no idea what is hunting them until the final moment. There are also animals so extraordinarily black that even direct light striking their bodies is barely reflected from the beam of a submarine searchlight. All that appears is a vast empty void. Scientists say this is not simply darkness. It is the place where light itself comes to die. Even more unsettling is the fact that every time a submersible descends into these depths, it returns with species no one has ever documented before. What does that suggest? It means that beneath the ocean below us exists an immense and largely unexplored world, still almost entirely unknown to humanity, and it may have been here far longer than humanity itself. Now, let's descend step by step into what is perhaps the most mysterious and restricted realm on Earth. At around 200 meters below the surface, sunlight starts to fade rapidly. This region is known as the twilight zone. It may seem logical to assume that where light weakens, life also disappears, but in reality, the opposite is true. Here, the natural world performs the largest migration on the planet. Each night, billions of lanternfish, squid and jellyfish ascend from the deep ocean to the surface in search of food. Then, before sunrise, they descend once more into the dark depths. This daily movement is known as vertical migration, and its total scale is greater than all migrations of land animals on Earth combined. Even more remarkably, people did not uncover this phenomenon until World War II. During that period, naval sonar repeatedly picked up what seemed to be a false ocean floor, one that rose each night and sank again during the day. At first, it appeared as though the seafloor itself was shifting. Later, scientists discovered that it was not the seabed at all, but living creatures. It was a vast hidden world, moving in rhythm like a living breath. Descend to a depth of 1,000 meters. And you arrive in what is known as the midnight zone. Here, there is no distinction between day and night, only unending darkness. Temperatures hover close to freezing, while the pressure reaches roughly 100 times that of the ocean's surface. In such an extreme environment, a human lung would be compressed to the thickness of a sheet of paper. Yet despite these harsh conditions, life has evolved astonishing adaptations. One remarkable example is the deep-sea dragonfish, which can produce red light, a rare ability in the deep ocean, especially since most other creatures living there are unable to detect it at all. It is almost as if the fish carries an invisible flashlight. In the lightless depths of the ocean, it can spot its prey with ease, while remaining completely unseen itself. Yet that is not even the most remarkable feature. One species has skin so extraordinarily black that scientists found it reflects just 0.5% of incoming light. Even when a submarine spotlight is aimed straight at it, it remains an empty abyss of pure nothingness. As scientists often put it, this is no ordinary darkness. It is a place where light itself comes to an end. Yet, among all the frightening creatures that inhabit the deep ocean, the anglerfish may be the most unsettling. The female anglerfish bears a small bioluminescent lure on her head, glowing and swaying through the lightless depths. In the deep sea's total darkness, smaller fish often mistake this flickering glow for food and swim closer. The anglerfish then stretches open its enormous jaws and devours its prey in a single snap, but even that is not the most disturbing part. What truly makes this creature remarkable is the way it reproduces. From the moment a male anglerfish is born. It has just one purpose: to locate a female. In the immense, dark expanse of the deep ocean, that task is almost impossibly difficult, and when he finally succeeds, he clamps onto the female, and releases an enzyme. It gradually absorbs into the female's body, until the two become fully fused. Over time, nearly all of the male anglerfish's organs waste away, and his only remaining role is to provide sperm. In one documented case, scientists discovered 8 of these permanently attached males on a single female. As unbelievable as it sounds, this is not science fiction, but a real reproductive strategy found in nature on Earth. At a depth of 4,000 meters, we reach the abyssal plain. This vast underwater region covers more than half of the planet's surface. Yet, it remains one of the least explored places on Earth. There are no coral reefs, no forests of seaweed, just immense plains of mud and sand, spreading for thousands of kilometers in every direction. Nutrients are incredibly limited here, but even in such harsh conditions, life has still managed to endure. When a whale dies, and its body drifts down to the ocean floor, scientists refer to the event as a whale fall. Far from being just a carcass, it becomes a major source of energy. In the deep sea, where food is often extremely scarce, the remains of a single 40-ton whale can support a complex ecosystem for decades, and, in some cases, for nearly a century. The process unfolds in stages. First, large scavengers such as sharks arrive and consume most of the soft tissue, often stripping away about 90% of it within a matter of months. After that, smaller creatures including crustaceans and worms begin to colonize the bones, turning the skeleton itself into a long-lasting habitat and food source. At the final stage, bacteria begin digesting the oils trapped inside the bones, releasing sulfides that nourish even more microorganisms. In the deep waters of the North Pacific, at least 43 species and tens of thousands of individual organisms depend completely on whale falls to survive. A single whale fall can sustain an entire ecosystem, allowing life to flourish in one of the ocean's most extreme environments. It is one of nature's harshest yet most quietly nurturing cycles. Far below, beyond 6,000 meters, lies the region is known as the Hadal Zone, a name derived from Hades, the underworld of Greek mythology. At these extreme depths, pressure rises beyond 600 atmospheres, roughly comparable to having the weight of 50 Boeing 747 jets, concentrated on a single fingernail. For a long time, scientists assumed no organism could survive under such crushing conditions. Yet in 2025, Chinese researchers released startling findings in the journal Cell that challenged this long-held belief. With the help of the Fendosia submersible, the team gathered more than 2,000 samples from the Mariana Trench. Their analysis revealed 7,564 kinds of microorganisms. And remarkably, 89.4% of them were previously unknown to science. What does that tell us? It shows that even in the darkest, coldest, and most intensely pressurized part of our planet, life does not merely survive, it flourishes in extraordinary ways. Humanity's understanding of the deep ocean has been fundamentally transformed. At the center of that shift is the Mariana Trench, the deepest known place on Earth, plunging to nearly 11,000 meters. To put that depth in perspective, even if Mount Everest were lowered into the trench, its summit would still remain about 1,600 meters below the surface. Conditions at this extreme depth are extraordinarily harsh. Pressure rises above 1,100 atmospheres, a force powerful enough to shatter glass. Yet, despite these challenges, humans first succeeded in reaching this remote abyss in 1960. What did researchers observe through the submersible? They spotted a flat fish, along with a tiny red shrimp. Despite the immense pressure at such depths, these creatures were not crushed. And the reason comes down to how their bodies are built. Deep-sea fish have remarkably thin, lightweight skeletons that are flexible rather than rigid. Their muscles are soft and pliable, and their cells contain a compound known as trimethylamine N-oxide. These adaptations help proteins remain stable even under immense pressure. More recently, a 2025 study reported that all deep-sea fish living at depths greater than 3,000 meters appear to share the same genetic mutation. That mutation enables their cells to operate normally in crushing high-pressure environments. In many ways, it represents an anti-pressure survival code, shaped by more than 65 million years of evolution. The deep ocean holds yet another remarkable mystery. In this dark, cold environment, time appears to move at an entirely different pace. The Greenland shark, a huge species that inhabits deep northern waters, is recognized as the longest living vertebrate on the planet. Using radiocarbon dating, scientists have estimated that some individuals can live for as long as 400 years. But what does a lifespan of 4 centuries really mean? It means that when one of these sharks was born, back then, China was still ruled by the Ming dynasty, the United States did not yet exist, and the Mona Lisa had only recently been completed. Since that era, this shark has continued gliding through the deep ocean, surviving across 4 centuries of human history. More remarkably, it grows at an extremely slow pace, just about 1 centimeter each year, and does not reach sexual maturity until around 150 years of age. Their early life lasts longer than the full span of recorded human civilization. Researchers have found that the Greenland shark's extraordinary lifespan is closely tied to one defining trait: slowness. It has an exceptionally slow metabolism, grows at a remarkably gradual pace, and maintains a very low heart rate. In the freezing, dark depths of the ocean, this near-motionless way of living helps it endure the passage of time. Yet the deepest ocean's biggest mystery is not one particular creature, but the entire ecosystem itself. For a long time, the standard scientific view was that deep-sea life depends mainly on organic material drifting down from surface waters. However, in 2025, Chinese scientists working in a trench 9,533 meters below sea level discovered an ecosystem that fundamentally challenges that idea. This newly observed community does not depend on sunlight. Rather than relying on organic material drifting down from the surface, these organisms survive on chemicals released from deep within the Earth's crust: hydrogen sulfide, methane, and dissolved metal ions, substances that are highly toxic to humans, serve as their source of energy and nourishment. Scientists describe this kind of habitat as a chemosynthetic ecosystem, a self-sustaining living world that exists entirely without sunlight. The importance of this discovery reaches well beyond our own planet, especially when considering places like Europa, beneath the icy crusts of moons such as Enceladus. In our solar system, scientists believe enormous oceans are hidden from view. If life can survive in the lightless depths of Earth's oceans without relying on sunlight, it is reasonable to ask whether similar life might also exist in alien seas. In that sense, deep ocean exploration on Earth could serve as a practical preview of humanity's future efforts to search for life beyond our planet. And yet, even as we are only starting to grasp the mysteries of Earth's deep sea, much remains unknown. We are already damaging this remote world. In organisms living at the deepest reaches of the Mariana Trench, scientists have detected microplastics as well as polychlorinated biphenyls, a group of synthetic industrial pollutants, known for their persistence in the environment. In other words, human-generated waste has arrived in some of the most inaccessible places on Earth, long before people ever physically reach them. This makes the fragility of the deep sea even more striking. Deep-sea manganese nodules grow extremely slowly, taking roughly 1 million years to add just a single centimeter. Deep-sea organisms often reproduce on timescales so slow, they can span centuries or even longer, making their life cycles extraordinarily fragile. Once these ecosystems are damaged or destroyed, recovery is extremely difficult, and, in many cases, may be effectively impossible. More ironically, despite covering most of the planet, over 80% of the world's oceans remain largely unexplored. Nearly every deep-sea expedition reveals previously unknown species, and each new sample has the potential to revise what humanity understands about life beneath the surface. In many ways, our knowledge of the deep ocean is still only in its earliest stages. A time shaped by gathering and hunting, roughly corresponding to the Mesolithic stage of human civilization, the deep ocean remains Earth's last great frontier. It is nearer to us than outer space, yet, in many ways it is even more enigmatic than Mars. Within its depths lie vital clues about how life began, how far evolution can extend, and how little we still understand about our own planet. Some believe humanity ultimately came from the sea, and perhaps The ocean has never really been gone. It is still there, hidden in the dark, buried beneath crushing pressure, thousands of meters below our feet, silently waiting to be explored. And the creatures of the deep sea do not rely on sunlight, they do not depend on oxygen in the way most life does, nor do they need any awareness of humanity's existence. If one day rising sea levels submerge the continents, in the end, it is humanity that may disappear, while they remain completely unaffected.